North Oaks Middle School. I'm Rayo Camacho.
And I'm Jacob Rodriguez.
Thank you, Jacob. On channel 3.14 with all of your science news.
Today we have breaking news about density and buoyancy.
Let's go to our on-site reporter, Zachary Trumpeturi, for that story.
That's
Trumpeturi here, coming to you live from a kiddie pool in somebody's backyard. I hope they're not awake right now. Anyways, I'm here to explain to you how buoyancy works. You see, buoyancy is the upward force that keeps objects, just like a basketball, afloat. As you can see, once it lands on top of the water, it floats. Now, a guy by the name of Archimedes discovered the law of buoyancy long ago. We will explain more about that later in the show. Now, another thing you should know about upward force is how hard it pushes. It's because of the depth. For example, if you were to try to float on a 3 feet kiddie pool, while the Atlantic Ocean is like thousands and thousands of feet deep, you'd have an easier time floating on the Atlantic Ocean, mainly because of the depth. The more depth you have, the greater the upward force has on you. Now, if you were to try to float on a kiddie pool like this, then you'll have a pretty hard time of floating. Alright, Zachary Trumpeturi here, back to you, Raul.
Thank you, Zach. Hello, and welcome back to your science news. I'm Jacob Rodriguez with my co-anchor,
Diego Rain.
and we have a special guest today. His name is Alexander.
He looks a lot like Raul does.
Yeah, but he's not.
Hey, why do I have the big laptop? You have the little one.
You know, that's a pretty poor choice.
Yeah. He said, hey, you switch it. Oh, thank you. Thank you.
Yeah, well, I guess the producer is an idiot.
Okay, like, can we just go back to Alexander, sir?
Yeah, I'm talking to you.
Let's go to
I
Alexander.
wouldn't do that.
We're switching to Alexander now.
Hello, people of the future. I'm Alexander of Sparta. I'm Archimedes' assistant. Of course, Archimedes is dead, but somehow I have lived through the centuries to tell you this story. Okay, Archimedes was a great man. You might know him because he was a guy who sat in a tub and yelled "Eureka" naked. But that's a different story. But today, I'm going to be talking to you about Archimedes' principle. Okay, so Archimedes' principle states that any object partly or wholly immersed in a fluid is buoyed up by an equal force, by a force equal to the weight of the fluid displaced by that object.
Hey everybody, it's Jacob Rodriguez, and I'm going to talk to you about density. Just don't tell Raul I'm here right now. I should be at the studio. Anyway, this ball of putty I have in my hand right now, let's say it has a mass of 10 grams and a volume of 5 cubic centimeters. If we follow the mathematical formula for density equals mass divided by volume, it would be 10 divided by 5, which equals 2. The density of water is 1. Theoretically, this ball of putty should sink. Now this is how they keep big boats on the ocean afloat, by using the simple mathematical equation.
Where are you?
Where? Now let's test our hypothesis. We said that this ball of putty had a mass of 10 grams and volume of 5 cubic centimeters. So if we follow the mathematical formula, it should equal 2. Therefore, it should sink in water. And it's correct.
OMG. Nearing the end of our newscast, but before we go, we have one more special guest.
His name is Diego Ray, and when he's not co-anchoring with me, he's professoring at a college named
Wakanugu. This, of course, is a real college. But yes, he is a very successful professor, and we will be videotaping him in one of his classes explaining buoyancy.
Alright.
Yes, Professor.
Master! Please zoom into the graph, please.
Yes, Professor Master, whatever.
Oh, whatever you say. You wanna leave this class?
I'm the cameraman, though.
As you see, if density is 1 and it's above this, it would float, and if it is below this, it would sink. Silly Putty would sink because it has a density of 2. Saturn would float because it has a density of 6.87. Oil will float. Penny will sink. Water will float.
You're going too fast, Master.
I don't care!
I'm sorry, Professor, but you're just dumb.
Aluminum will sink because it's
Aluminum?
aluminum! As I was saying, salt will float because it has a density of 0.92. And humans, the light just went off. Don't touch the light.
Don't touch the light!
Thank you. You get the all, and you get up something.
Up what?
And humans, they can float. Okay, class, did you learn everything?
Yes,
No.
master.
Hello, our loyal viewers. This is your whole 3.14 channel anchor team right here, all 4 of us, with your final experiment. Thank you, Diego, for that interesting lecture, by the way. Okay, so right here on our final experiment, we have 1 cup of salt water, 1 cup of tap water, and a bowl of vegetable oil. I'll be behind the camera while Jacob, Zach, and Diego explain.
Okay, now as Professor Diego explained, the aluminum foil sinks in the water. But we made our research and we found out that salt water is more dense than regular water.
In which case, this should float.
Exactly. So, this hypothesis is going to be, does aluminum foil float on salt water? Well, we're about to find out. Alright.
Here we go.
Master Diego, put yours in. And according to this, it floats.
It's spinning, and it's still floating, so it floats.
Alright.
It floats.
Let's see how the tap water fares. Sorry. Alright. 3, 2, 1. Huh. Apparently, it floats.
And it's still
That's not
floating.
gonna float. Piece of crap's not gonna float, guy.
Okay.
I will make it sink. Oh, look, it's sinking!
Well, apparently you have to put some force on it. But in some cases,
see, over here, it won't sink.
in some cases it sinks. In other cases, it floats.
It's a really random
See,
situation.
no matter how much you try,
I mean-
you can't get it to sink over here.
All right.
But it
Now
will
let's
sink.
do the
Thank
vegetable
you.
oil.
Let's do the oil.
Yes. Now I have mine. 3, 2, 1. Drop and
And
sink.
Obviously, it sinks.
It did sink because why?
Because oil
is less dense
than water.
Very good.
So
Now let's test this out to prove even more. We have our oil and we're gonna pour it into the water. As you can see, it floats on top of the water.
if you get a side view, then you'll be able to see much clearer that the oil is, in fact, on top of the water.
So, thus proving even more that oil is less dense than water. Okay, so now let's
All right.
say goodbye to our viewers, guys. Let me get
This is channel 3.14 signing out.
Peace.
All right. See ya.